Hello dear students, welcome to our first trigonometry lesson. Today we'll be talking about the main trigonometric ratios for an acute angle. As you can see here, in a right triangle ABC, for angle A, BC is considered the opposite side, where AB is considered the adjacent side and AC is considered the hypotenuse. Then sine angle A is the opposite over hypotenuse, which is CB over AC, where cosine A is adjacent over hypotenuse, that is AB over AC, where tan A is the opposite over adjacent, which is CB over AB. For measuring the angle, we can use the circular measure that we can write it in degrees, minutes, and seconds. Let's now move to example 1. How to write 38.5 degrees into degrees, minutes, and seconds. It's very simple, just you do it with a calculator. You type on your calculator 38.5, after you press equal, then you press on the degrees, minutes, and second button that is there under the square root. It's the button that is under the square root. If you press on it, it will appear to you that it's 38 degrees, 30 minutes, and 0 seconds. If you go to question 2, 120 and 1/8 degrees, you write a mixed number, 120 and 1 over 8, you press equal, then you go and press on the degrees, minutes, and second button on the calculator that is there under the square root button. It will appear to you that it's 120 degrees, 7 minutes, and 30 seconds. Example 2. If the ratio between two measures of complementary angles is 3:5, find the value of each angle. Here, if the question says that there are two complementary angles, automatically we know that the complementary angles, their sum is 90 degrees. So we're going to say that the first angle is 3x plus the second angle, which is 5x, equal 90, then 8x is equal to 90, then x is equal to 11.25. To find the measure of each angle, the first angle is 3 times 11.25, which is 33.75 degrees. If you want to write it in degrees, minutes, and seconds, it will be 33 degrees and 45 minutes. The second angle, it's 5 times 11.25, that is 56.25 degrees. If you want to write it in degrees, minutes, and seconds, it will be 56 degrees and 15 minutes. Question 3, the question says, ABC is a right angle triangle at C, where AB is 13 centimeters long and BC is 12 centimeters long. The first part of the question wants us to find the length of AC. That's very easy. Yes, I can see that you guys said Pythagoras. So to find the length of AC, we use the Pythagorean theorem. Then AC squared equals AB squared minus BC squared. Then AC equals the square root of 13 power 2 minus 12 power 2, which is 5. Then here the length of AC is 5 centimeters. So AC is 5 centimeters. Part B, the question is asking us to find sine A, cosine A, tan A, sine B, cosine B, and tan B. The question wants us to find sine A. So you go to angle A. Where is the opposite to angle A? Yes, right, the opposite is 12. And where is the hypotenuse? It's 13. So sine A is opposite over hypotenuse, which is 12 over 13. Now let's go and do cosine A. Cosine A is the adjacent over the hypotenuse. So adjacent of angle A is the 5, and the hypotenuse is the 13. Tan A is the opposite over the adjacent. So the opposite is 12, where the adjacent is 5. Let's now do sine B. Remember and take care that the opposite and adjacent sides will be changed according to the angle. Sine B. Where is the opposite of angle B? It's the 5 over the hypotenuse is 13, where cosine B is the adjacent, which is 12, over the hypotenuse, which is 13, and tan B is opposite, which is 12, over the adjacent, which is 5. Let's now go and check question C. Question C wants us to prove that sine A times cosine B plus cosine A times sine B is equal to 1. We're now going to go to the left-hand side. So sine A times cosine B plus cosine A times sine B. Let's now use the values that we got in question B. Sine A, that was 12 over 13, multiplied by cosine B, which is 12 over 13, plus cosine A, that is 5 over 13, multiplied by sine B, which is 5 over 13. When you do your calculations, you will see that this is equal to 1. So here we prove that sine A cosine B plus cosine A sine B is equal to 1. Let's now move to example 4. ABC is a triangle in which AB is equal to AC is equal to 10 centimeters, where BC is equal to 12 centimeters. So here's the triangle, where it is an isosceles triangle that AC is equal to AB. Drawn that AD is perpendicular to BC, where AD intersects BC at point D. The question wants us here to find the value of sine angle CAD, cosine angle CAD, and tan angle CAD. As long as this is an isosceles triangle, so this perpendicular line bisects BC. So the CD is now 6 centimeters long and the BD is also 6 centimeters long. Let's now get the length of segment AD. Then AD, using Pythagoras, equals the square root of 10 squared minus 6 squared, which is 8 centimeters. So AD now we got it as 8 centimeters. How can we find sine CAD? Sine CAD equals, here is angle CAD. So we know that sine is the opposite over hypotenuse. So it's the opposite, which is CD, that is 6, over the hypotenuse, which is AC, that is 10. If you simplify this, it would be 3 over 5. With the same way, let's find cosine CAD. It's adjacent, the 8 over the hypotenuse, which is 10, if you simplify it, it would be 4 over 5, where tan CAD is opposite over adjacent, which is 3 over 4. The second part of the question, it says, prove that sine B plus cosine C is greater than 1. Let's now find sine B. Sine B is equal to opposite over hypotenuse, which is 4 over 5. And cosine C, it's equal to adjacent, which is 6, over the hypotenuse, which is 10. That would be 3 over 5. Let's now check that 4 over 5 plus 3 over 5, it's equal to 1.4, that is greater than 1. Example 5 says, ABCD is an isosceles trapezoid, where AD is parallel to BC, and AD is 4 centimeters long, and AB is 5 centimeters long. And also, BC is 12 centimeters long. Let's now first go and draw the trapezoid. Here's the trapezoid, where AD is 4 centimeters, AB is 5 centimeters, and as long as, and this is an isosceles trapezoid, so for sure CD is also 5 centimeters long. And here the BC is 12 centimeters long. Let's now construct DF perpendicular to CB and AE perpendicular to CB. And here, for sure, FE is 4 centimeters long, and CF is 4 centimeters long, and EB is 4 centimeters long. Now, the question wants us to prove that 5 tan B times cosine C over sine squared C plus cosine squared B is equal to 3. Let's now go and find every trigonometric ratio that we want. So, here's the fraction that we want us to prove. 5 times, what's tan B? We go here to angle B. How can we find AE? We can easily find AE using the Pythagorean theorem. So AE equals square root of 5 squared minus 4 squared. So AE is 3 centimeters long. And the same as here, the DF is also 3 centimeters long. So for angle B, tan B is opposite over adjacent, so it's 3 over 4 times cosine C, for cosine is adjacent, over hypotenuse, which is the 4 over the 5 for angle C, over sine squared C. Sine C is opposite over hypotenuse, so it will be 3 over 5 all squared plus cosine squared B, which is 4 over 5 all squared. If you calculate this on your calculator, the result will be 3. So here we prove that this fraction is equal to 3. Let's now go to the evaluation part. The first question, it says, write each of the following angles in degrees. Again, we get our calculators. How to write 76 degrees 16 minutes. Using your calculator, you write 76, and then you press on the degree, minutes, and seconds button that is under the square root, and then you write 16, you press on the same button again. Then the answer that you'll get on the calculator will be 76.27 degrees. Question B, it will be 45.07 degrees, or question C, it will be 85.64 degrees. Question 2, how to write each of the following angles in degrees, minutes, and seconds. Question 1, the answer will be 34 degrees and 36 minutes, where question 2, it will be 78 degrees, 4 minutes, and 48 seconds. And now, dear students, we came to the end of our session today. Thank you very much. Wishing you best of luck.